So this is just an example of what microcephaly looks like. In the middle you can see a baby affected with microcephaly, and then there's also an example of severe microcephaly. This is also another example of a child with microcephaly. So Zika teratogen. So first of all, teratogen is an agent or factor that causes the malformation of an embryo. So to be a teratogen, something must fit the following criteria. So there must be proven exposure to an agent that occurs at a critical time during prenatal development. 2 epidemiologic studies of high quality support the association. Careful delineation of clinical cases with the finding of a specific defect or syndrome. There should be an association between a rare exposure and a rare defect because this implies causation. The last 3 are not essential, but it does not hurt to fulfill these requirements. So, need for an animal model that shows teratogenicity, an association should make biological sense, and proof in an experimental system that the agent acts in an unaltered state. So is Zika teratogen? So it fits the first criteria because severe microcephaly and other brain anomalies have been observed in many infants, and are consistent with an infection, a Zika infection occurring in the first or early second trimester of a pregnancy. The second criteria was not met, however the third one was met because many fetuses and infants with presumed congenital Zika virus infection have had a typical pattern, including severe microcephaly, along with other things. Microcephaly is rare and only occurs in 6 infants per 10,000 born in the United States. Zika isn't necessarily rare for women living in Brazil, but reports of adverse birth outcomes among travelers who spent only a limited time period in the area where there is active Zika virus transmission are consistent with Zika virus being a rare exposure. So it fulfills the 4th criteria.